Good morning to all. Today we'll start the article continuity. Today we start the continuity. In the definition of f of x, f of x tends to L as x tends to x0. The function f of x need not be defined at x is equal to x0. Hence, the consideration of f of x0 does not arises. However, when f of x is defined at x is equal to x0, the situation will be different. In such case, we have either f of x0 is equal to L or f of x0 is not equal to L. Is not equal to L. If f of x0 is equal to L, we say that f of x is continuous at x is equal to x0. We will see the definition of continuous function. We should see the definition of continuous function. Continuous function. What is continuous function? A function if is said to be continuous, if is said to be continuous at x is equal to x0 if limit of a function f of x as x tends to x0 is equal to f of x0 or limit of a function f of x as x tends to x0 plus, this is right hand limit of a function f of x is equal to left hand limit of a function f of x, that is limit as x tends to x0 minus, this is left hand limit of a function f of x is equal to f of x0. Function is said to be continuous when right hand continuous function and left hand continuous function is same, then that function is also continuous function. When right hand limit exists is equal to left hand limit, then this function is continuous function also. So that can be written as f of x0 plus is equal to f of x0 minus is equal to f of x0. Now, this condition, limit of function f of x at x is equal to x0 is equal to f of x0, can be written in this form. This condition can be written in this form limit of a function f of x as x tends to x0 is equal to function of limit of a function x as x tends to x0 as x tends to x0 is equal to f of x0. Thus the continuity of f of x at x0 implies that thus the continuity of f of x at x0 implies that f of x must be defined at f of x must be defined at x0, that is f of x0 must exist and second, limit of a function f of x at x tends to x0 must exist and third one is limit of a function f of x as x tends to x0 is equal to f of x0. If any one of above evaluated f of x fails to be continuous at x is equal to 0. Now in this continuous function f is said to be continuous at x is equal to x0 if this function f of x, limit of a function f of x as x tends to x0 is equal to f of x0 when this satisfies, or when right hand limit of a function and left hand limit of function exist, they are equal, then f of x0 is also, this is also is equal to f of x0. That means f of x0 plus is equal to f of x0 minus is equal to f of x0, and this can be written as, this condition can be written as limit of a function f of x at x is equal to x0 is equal to function f of a limit of a function x as x tends to x0 can be written as f of x0. Thus the continuity of f of x at x0 implies that f of x, this function f of x must be defined at x0, defined at this x0 must exist, and limit of function f of x at x tends to x0 must exist, and this limit of a function f of x at x is equal to x0 is equal to f of x0. So this is the definition of continuous function. Now when function is said to be, now we'll see the discontinuity of the function. Discontinuous function, we will see the discontinuity. discontinuous function. When function f of x is not continuous at x is equal to 0, is said to be discontinuous at x is equal to 0. And the point x0 is called discontinuity of f of x. So we will write systematically. When the function f of x is not continuous at x0, it is said to be discontinuous at x0, discontinuous at x0. The point x0 is called the point x0 is called the discontinuity of f of x. The discontinuity of f of x. Now we will see some examples about continuous function or discontinuous function. Let, suppose this is number 1, let function f of x is equal to x square, and the number x, which belongs to the set of real lines, are x belongs to the real line R, and here limit of a function f of x as x tends to 3 is equal to limit as x tends to 3. So f of x is 3. F of x is equal to x square. So in place of x we have 3 square as it is. So what you get? This is equal to 3 square is equal to 9. Also what about f of 3? F of 3 is equal to f of x, and f of x is equal to x square. So that is 3 square. 3 square is equal to 9. And therefore limit as x tends to 3 of a function f of x is equal to f of 3. So, and this both implies that this is equal to 9. F of limit of function f of x as x tends to 3 is equal to f of 3, both are equal. So this implies that f of x is continuous. F of x is continuous. continuous at x is equal to 3. X is equal to 3. Then we'll see the example about discontinuous function. This is the example about continuous function. Very easy example. Let f of x is equal to x square. F of x is equal to x square if x is not is equal to 3, and f of x is equal to 2 at x is equal to 3. Now we want to verify this function is continuous or discontinuous. So now limit of a function f of x as x tends to 3, what we have, this is equal to limit as x tends to 3 of a function f of x, and that f of x is equal to x square. So this can be written as 9. And what about f of 3? So f of 3 is equal to limit as x tends to 3 is 3 square is equal to 8, not 3 square. F of 3 is equal to what we have? F of 3 is equal to f of 3 is equal to 3. Function f of x so f of 3 is equal to 3 because x is equal to 3. So f of x is equal to 2. F of x is equal to 2 at x is equal to 3. Therefore, what we have? We have f of 3 is equal to 2. So from these two, limit of a function f of x at x tends to 3 is not equal to f of 3. Therefore this function is continuous. Therefore f of x is not continuous at x is equal to 3. Is not continuous at x is equal to 3. Now you see the epsilon minus delta definition of continuity. epsilon minus delta. Definition of continuity. Definition of continuity. Definition of continuity. Function f of x is said to be continuous at x is equal to x0 if for any epsilon is greater than 0 there is a delta is greater than 0. The function f of x is said to be continuous at x is equal to x0 if for any epsilon is greater than 0 there is a delta which is greater than 0 such that mod x minus x0 is strictly less than delta, and this implies that mod f of x minus f of x0 is strictly less than epsilon. This is the epsilon minus delta definition. A function f of x is said to be continuous at x is equal to x0 if and only if for any epsilon is greater than 0 there is a delta is greater than 0 such that mod f of x minus x0 is less than delta implies that mod f of x minus f of x0 is less than delta. Means the function f of x is said to be continuous at x is equal to x0 if for any epsilon is greater than 0 there is a delta is greater than 0 such that this mod x minus x0 is less than this delta, and this term implies that mod of f of x minus f of x0 is also less than epsilon. Now we'll see the example. Prove that f of x is equal to x square is continuous at x is equal to 3. We show that for any epsilon is greater than 0 we can find a delta depending on this epsilon such that mod x minus x0 is strictly less than delta, and this implies that mod f of x minus f of 3 is strictly less than epsilon. Let this epsilon is greater than 0 be given and let delta is less than or is equal to 1, then this mod x minus 3 is strictly less than delta. This implies that mod x minus 3 is strictly less than 1 because delta is less than or is equal to 1. That means that is 3 minus 1 is less than x and this x is less than 3 plus 1, or this can be written as 2 is less than x is less than 4. So now this mod f of x minus f of 3 is equal to mod f of x is x square and f of 3 is 9. So what do you get? This can be written as mod of x minus 3 into mod of x plus 3. So this is strictly less than delta. In place of this we have delta into 4 plus 3, and what do you get? You get 7 delta. And if this delta is less than or is equal to epsilon by 7, then this mod f of x minus f of 3 is strictly less than epsilon. Then for delta is equal to minimum of 1 epsilon by 7, this implies that f of x is a continuous at x is equal to 3. Now we have proved this statement. Now see the function f of x is said to be right continuous or left continuous. Now see the definition of right continuous function. Right continuous function. Right continuous function. Right continuous function. The function f of x is said to be right continuous at x0 if f of x0 plus is equal to f of x0. Now we will write systematically. This is function f of x is said to be right continuous at x0 if f of x0 plus is equal to, in this case f has to defined only for x is greater than or is equal to x0, and f is defined on the interval of the form x0b, and we say that f of x0, f of x tends to f of x0 as x tends to x0, as x tends to x0 from the right, and the epsilon minus delta definition takes the following form. A function, I will write systematically, a function f of x is said to be right continuous at x0 if for each epsilon is greater than 0, there is a delta is greater than 0 such that x0 is strictly less than x, and this x is strictly less than x0 plus delta, and this implies that mod f of x minus f of x0 is strictly less than epsilon. This is a definition for epsilon minus delta, and our regular definition is a function f of x is said to be right continuous at x0 if f of x0 plus is equal to f of x0. This is the definition of right continuous function. Now see the definition of left continuous function. Now left continuous function. Left continuous function. A function f is said to be left continuous function at x0 if f of x0 minus is equal to f of x0. So I will write systematically a function f is said to be function f is said to be left continuous at x0 if f of x0 minus is equal to f of x0. In this case f is defined on the interval of the form Ax0 thus a function f of x is said to be left continuous if for each epsilon is greater than 0 there is a delta is greater than 0 such that x0 minus delta is strictly less than x and this x is less than x0. This implies that mod of f of x minus f of x0 is strictly less than epsilon. Now we will see the example for this. Suppose we have f of x is equal to 2x cube minus 1 and the interval 1 is less than or equal to x is strictly less than 3. So we have limit of a function f of x as x tends to 1 plus right continuous limit is equal to f of 1 plus and this is equal to limit of a function f of 1 plus h as h tends to 0 is equal to limit as h tends to 0 of a function this. So 2 in bracket 1 plus h cube minus 1. So what you get? You get this is equal to 2 minus 1 is equal to 1. And also f of 1 is equal to, also f of 1 is equal to 2. We have the function 2x cube minus 1. So in place of x there is 1. 2 into 1 cube minus 1. What do you get? You get this is also equal to 1. And therefore what you get? This implies that limit of a function f of x as x tends to 1 plus, that is right hand limit, right hand continuous function is equal to f of 1 plus is equal to f of 1, and that f of 1 is 1. And therefore this implies that f of x is a right continuous at 1. This implies that f of x is right continuous at 1. So with example we discuss the concepts. And this is for right continuous. What about left continuous? So here f of 3 is equal to 2 3 cube minus 1 is equal to 53. And since f of 3 minus is equal to f of 3, so f of x is a left continuous at x is equal to 3. F of x is a left continuous at x is equal to 3. This is the concept of left continuous function and right continuous function with the example. Now we'll see the continuity on an interval. Continuity on an interval. Function f of x is said to be continuous on an interval I if it is continuous at all points of interval I. So I will write systematically continuity on an interval. A function f of x is said to be continuous on an interval I on an interval I. If it is continuous, if it is continuous, it is continuous at all points of I, at all points of I, at all points of I. Now continuity on a closed interval. We'll see the continuity on a closed interval. Closed interval. This is the definition of continuity on a closed interval. Let the function f be defined on AB, then f is said to be continuous, then f is said to be continuous, on AB if and only if limit of a function f of x as x tends to x0 is equal to f of x0 for a is less than x0 and x0 is less than b. F of x0 plus is equal to f of a, and f of x0 minus is equal to f of b. Let the function f be defined on the closed interval AB, then f is said to be continuous on AB if and only if limit of a function f of x as x tends to x0 is equal to f of x0 for this a is less than x0 and x0 is strictly less than b, and f of x0 plus is equal to f of a and f of x0 minus is equal to f of b. Now today we'll stop here. Tomorrow we'll see some examples of next article. Okay, today we'll stop here. Thank you.